Hi, in this video, I'm going to demonstrate how to solve logarithmic equation. Do visit this link if you find this video is useful. This is a logarithmic equation because in this equation it contains the log term. When we ask to solve a logarithmic equation, basically we are supposed to find the value of x that satisfies this equation. Allow me to relate to something that you are familiar. For example, solve 2x plus 1 is equal to 5. So we know that 2x will be equal to 5 minus 1, and x will be 4 divided by 2 will give us a 2. Then we check back. If we substitute 2 into here, 2 times 2 plus 1 will give us a 5. And indeed, the right hand side of the equation is 5. Therefore, we say that x equal to 2 satisfies this equation. That is the meaning of solve. Again, solve basically is to find the value of x that satisfies this equation. So here, how are we going to find the value of x that satisfies this logarithmic equation? Okay. Before we can do that, we have to know one fact about logarithm. If log base a m is equal to log base a n, these two base is the same, we can conclude that this m and this n, they are equal. Okay. You can apply this property provided the base of these two logarithms, they are the same. Let's go back to our question. Log base 2 x plus 1 is equal to log base 2 5. So from here we can conclude that x plus 1 must be equal to 5 because they have the same base. And x will be equal to 4. Let's do a check. If we substitute x equal to 4 into here, 4 plus 1 will give us a 5. Log base 2 5 is indeed equal to the log base 2 5 on this side of the equation. Let's take a look at a slightly more complicated example. Example 2. In example 2, we have 2 log on this side of the equation and 2 log on this side of the equation. If we want to solve the logarithmic equation, we have to combine the 2 log into a single log, just like example 1. Similarly, we have to combine these 2 log into a single log. Okay, how are we going to combine the 2 log into a single log? Well, we can apply the law of logarithm. There's this law of logarithm that say log base a x multiplied by y can be rewritten as a sum of 2 log. That is log base ax, log base ay. A multiply here can be rewritten as a plus here. Similarly, log base a, instead of x multiplied by y, we have x divided by y. Okay. We can rewrite this as log base ax, log base ay. A divide become a minus here. Okay. So based on law number 1, when we have 2 log, we can combine these 2 log into a single log. Okay. Therefore, we can combine these 2 log, sum of these 2 log as a single log with the same base, and the expression inside is going to be multiplied together. So we are going to take 2x multiplied by x plus 1. On the right hand side of the equation, because this is a subtraction, so we have to apply law number 2. Okay, these 2 log can be stringed into a single log, and the expression inside the log will be x divided by y. These 2 log can be stringed into a single log, and the expression inside will be this expression here divided by 0.5. Now we have log base 10 of this expression equal to log base 10 of another expression. Okay, we can conclude that this expression here must be equal to this expression because now these 2 log have the same base. Okay, if I were to bring the 0.5 to here, I will have x squared plus x is equal to 3x. Okay, or x squared minus 2x is equal to 0. X minus 2 is equal to 0. I will have x equal to 0 or x equal to 2. Now we have two value of x. We have to check back whether these two value of x valid or not. So let's check the value of x equal to 0. If I substitute x equal to 0 into this equation here, 2 multiplied by 0 will be a 0. Log of a 0 is undefined. For log to be defined, the value of x, right, must be greater than 0. Okay. Again, if we substitute x equal to 0 into this equation, we have log 0. Okay. Log 0 is undefined. Log 0 or log of a negative value is undefined. That is to say, we have to reject this answer. Let's check x equal to 2. If we substitute 2 into here, we have log of 4, which is valid, and log of 4 plus 1, which is 5, which is valid, log of 12, which is valid. And here there's no x. So that means x equal to 2 will satisfy this equation here. Okay. In example 3, what is unusual here is we have a constant. If you want to solve a logarithmic equation that involves a constant, you have to change this constant into a log expression. How to change this constant into a log expression? Well, there is this law that say log base a, if this letter and this base here, the letter of this base is the same, the result here will be a 1. Therefore, this 1 here, we can change to log of a base and a number here. These two boxes here must be of the same values. So now, how to decide what is the value of this box here? Well, we can see that the base of the log here is 4. So when we change the 1 to a log of a base, the base we want to follow as 4 as well. And because this is 4, here must be 4. Because log base 4 will give you a value of 1. Log base a will give you a value of 1. This is another law of logarithm. Okay, now this is a log and this is a log. Okay, we have two log. We are going to combine the two log together. Okay, however, we have a problem. Can we just combine the two log like this? Not exactly, because of a 2 here. You cannot apply law number 2 because law number 2 say if you want to combine two log together when they are a subtraction, the coefficient of these two log must be a 1. The coefficient of this is a 1, no problem, but the coefficient of this is a 2. So how to make the coefficient of this log to be a 1? You have to apply law number 3. Law number 3 say if you have log base ax raised to the power of a number, this number you can bring down. That is n log base ax. If we can bring down this number, obviously we can bring up this number as well. That is, these two we can bring up. It will give us log base 4 x plus 1 square minus log base 4. Okay. Now we have two log and they subtract each other. We can apply law number 2. Notice they have a same base, so we can apply law number 2. We take this expression, divide by this expression. Okay, let me copy down this expression here. Okay, so we can conclude that x must be equal to x plus 1 square divided by 4. Therefore, x is equal to x plus 1 square divided by 4. Or 4x is equal to, if I were to expand this, factorize this quadratic equation, x will be equal to 1. Okay, let's check whether x equal to 1 is a valid answer. If you substitute 1 here, this will give you a positive 1, so no problem. If you substitute 1 into this expression, it will give you a positive 2, no problem. Therefore, we can conclude that x equal to 1 is a valid answer and it satisfies this equation. Again, in this question, we have a constant in the logarithmic equation. We have to change this constant to a log expression, so much so that we can combine the log expression into a single log. Okay, that's why whenever you encounter a constant, you have to apply this property to change the constant into a logarithmic equation. Let's say if you have a constant 2, how are you going to change the constant 2 into a log expression? Well, 2 I can rewrite as 2 multiplied by 1. And 1 I can rewrite as log base 4. Okay, so I've changed this constant 2 into a logarithmic equation. Similarly, if you have a 3, you can just rewrite as 3 multiplied by 1, and 1 you can always rewrite as log base 4. Okay, why I have to rewrite as log base 4? Because the base of this question is 4, so I will follow the question. Let's take a look at question number 4. In question number 4, we realize that the base of these two log is not the same. If the base of the two log is not the same, we cannot apply law 1 or law 2 to shrink the two log into a single log. Okay, so now we have to change this 3 to a base of y, or change this y to a base of 3, so much so that we can apply law number 1 to shrink the two log into a single log. How are we going to change the base of a log? Well, that is law number 5. Law number 5 say if you have a base of a, and if you want to change to a base of, let's say, b, you can rewrite this as log base b. The assumption here is we are going to change the log base a to log base b. You write log base b first, divide by another log base b, followed by this n divided by a. This n divided by a. Okay, so basically, this is the way to change a base. Okay, maybe I would like to give you one more example. Let's say log base 2, 3. Okay, if you want to find the value of this, okay, our calculator don't have a log base 2. So what we can do is, if we really want to find the value, we can change to log base 10. To change to log base 10, we have to apply this expression here. Okay, the way to remember is this. I'll write log base 10 first, divide by another log base 10. I'll take the 3 over the 2. The 3 over the 2. So now, in your calculator, you go and press this value, divide by this value. You get the answer for log base 2, 3. Let's go back to our question. I can either change this to base of y, or change this to a base of 3. And I would like to change this to a base of 3. Why? Because I'm more comfortable if the base is a constant rather than a variable y. So now I'm going to change this log into a base of 3. How to change? I'll write as log base 3 first, followed by another log base 3 here, and 3 over y. 3 over y. Now I'm going to copy down this expression, equal to 4. Okay. And what happened? Log base 3 will give us a value of 1. This is law number 4. Log base AA will give you a value of 1. So this will be 4 divided by log base 3y, and log base 3y is equal to 4. Now, how to solve this equation? Well, I see that there is a log base 3y here. There is a log base 3y here. Okay, what I'm going to do is I'm going to let u to be log base 3y. If I let u to be log base 3y, this expression will turn out to be u plus 4 over u equal to 4. Okay, now I'm going to find the value of u that satisfies this equation. Okay, multiply the u throughout. I will have a quadratic equation. So u 2, 2. So u will be equal to 2. Okay, but remember, what we are supposed to find is y, not u. So our u is log base 3y. I'll put back my u as log base 3y is equal to 2. Okay, and 2 I can rewrite as 2 multiplied by 1. I'm going to change this to a log. Okay, so I write 2 as 2 multiplied by 1, and 1 I can rewrite as log base 3 3. Okay, log base 3 3 will be give us a value of 1. Why the base of 3? Because I see the base of this log is 3, so this will follow this, and this 2 I can bring up, so log base 3y will be equal to log base 3y squared. And now this is log base 3 on this side of the equation, this is log base 3 on this side of the equation. We can conclude that y will be equal to the 3 square, equal to 9. Okay, so y will be, y take the value of 9. It's always good to check back whether your answer is valid. If y is 9 here, no problem, 9 is greater than 0. If you have a base of 9, no problem as well. Okay, therefore y equal to 9 is a valid answer. This is a full solution of these questions. Now let's take a look at example number 5. In example number 5, on this side of the equation we have one log term, which is good. But on this side of the equation we have two log term. So we have to combine these two log term into a single log term. Okay, but before we can combine, make sure the coefficient of the log is a 1 and 1 here. However, now this is 3, so I have to get rid of the 3. How to get rid of the 3? Well, we can always bring this 3 up here by applying this law 3 of logarithm. So that is log base 4 16x plus log base 4 half. Bring up the 3, here will be a power of 3 here. And now we can combine these two log into a single log. A plus become, when we combine to a single log, will become a multiply. Half to the power of 3 will give you 1 over 8. Simplified this expression will give you a 2x. That is log base 16 3x plus 1 is equal to log base 4 2x. Can we conclude that 3x plus 1 is equal to 2x? The answer is no, because here we have base of 16 and here we have base of 4. The base of this log and the base of this log, they are not the same. So we cannot conclude that 3x plus 1 is equal to 2x. Okay, how are we going to solve this problem? What we can do is either we change this base of 16 to a base of 4, or so that they have the same base, or we change the base of 4 to 16. Now whenever you have a choice like this, always change the base of a bigger number to a base of a smaller number. That is, we should always change the base of 16 to base of 4. Okay, change to a smaller base rather than a bigger base. So we'll change the base of 16 to base of 4. So now, if we are going to change base of 4, base of 4, it will be 3x plus 1 over 16. Okay, I'm applying this law here. Okay, now let's zoom into this expression here. Log 416. Can I simplify this expression? Yes. Log 416 I can rewrite as log 4 square. And these two later I can bring down, okay, by applying this logarithm law. Okay, let me put back this equal to this expression. So 4 3x plus 1 divide by this expression will give us a value of 2, because when you bring down the value here, it will be a 2 here. Log 4 will give you a value of 1. Okay, so 2 multiplied by 1 go to log base 42x. So I'm going to bring the 2 over. You have a 2 log base 42x. Now can I conclude that 3x plus 1 is equal to 2x? No, not yet, because there is a 2 here. If you want to do a comparison, the number here and the number here must be the same. So what I can do is the 2 I can bring up. So become log square. Okay. Now we can conclude that 3x plus 1 is equal to 2x squared. Or 3x plus 1 equal to 4x squared. 4x squared minus 3x minus 1 equal to 0. So 4x x 0, okay, minus plus, it will give us x to be minus 1/4, or x is equal to 1. Okay, when x is minus 1/4, when x is minus 1/4, okay, this value here will give us a negative value. So minus 1/4 is not allowed here. Okay, when x is 1, this is positive. X is 1, this is positive. So x is equal to 1 is a valid answer. So we conclude that we have to reject this answer. We have to reject this answer and conclude that x take the value of 1. Let's conclude our learning of solving logarithmic equation using one last example. Okay, now we have a constant here. If you encounter a constant in a solving of logarithmic equation, what you should do is you should convert the constant into a log expression. Again, how to convert into a log expression? This constant half here I can rewrite as half multiplied by 1. Half multiplied by 1 is still a half. So what is the advantage? Because this one here, we know that we can always rewrite this as log base of a number. Okay, now the problem is, what is the base we should choose? We have a base of 4 and base of 16. Between 16 and 4, we should choose a smaller base. When we choose a smaller base, it will make our calculation easier. So now the base we're going to choose will be 4. If this is 4, here must be 4. Why? Log base 4 will give you a value of 1, which is law number 4. So now we have a log expression here and a log expression here. We can combine the two log expression together. But before we can combine the two log expression together, we have to get rid of this half. How? This half we can always bring up here. We are applying law number 3. Okay, the n we can always bring up. Oops. So bring up the half will be here. Now we can combine the two logarithm together. A minus will become a divide. 4 to the power of half is actually a 2, so divide by 2. So again, can we say that x minus 1 is equal to x plus x divided by 2? No. Why? Because their base is not the same. So we have to change the base to be the same again. And between 4 and 16, 4 is a smaller number. So we are going to change the 16 to the base of 4. X minus 1 divided by 16. So 16 again we can rewrite as 4 square. And these two we can always bring down later. So this, if you bring down the 2 multiplied by log 4 log 4 will be a 1. So 2 times 1 will be a 2. Again, we bring over the value of 2. And these two again we bring up so that we can compare this side and this side of the equation. If you bring up, it will become a x squared over 4. X minus 1 must be equal to this. So 4x minus 4 equal to x squared. X squared minus 4x plus 4 equal to 0. X minus 2 squared is equal to 0. X will be 2. Okay, so we check. When x equal to 2, 2 minus 1 will give you a positive 1, no problem. Log base 4, 2. Okay, 2 is a positive number, no problem. So x equal to 2 is a valid answer. X equal to 2 is a valid answer. Again, if you like this video, do visit this link. Thank you.